Buffering capacity refers to how much of a strong acid or a strong base the buffer can absorb and still maintain its fairly constant pH. So if we take the Henderson-Hasselbalch equation, and then remember this can be moles because the volumes would cancel out. What we have is a situation where if we add the strong acid is going to react with the conjugate base, and we'll just get this. And if we were going to add a strong base, the strong base would react, and we would get this as a result. So when we are talking about the capacity, what we mean is how many moles of this one do we have and how many moles of this one. And what happens when you add more, let's say we had 1/10 of a mole of A minus, well, the buffer will hold until we add more than 1/10 of a mole of the H plus. And remember, these reactions are not equilibrium reactions. This slide really is just reiterating the same point that I made before, and that is that typically buffers, or the best buffers, occur when the concentration of the acid is pretty close to the concentration of the conjugate base, because you want the buffer to withstand changes by either addition of a strong acid or a strong base, so you want to make sure that the buffer itself can react with either of those. If you need to prepare a buffer at a particular pH, you use the Henderson-Hasselbalch equation, and you find a buffer system where the pKa is close to the pH that you want. And if you can't find one that's exactly right, then you can adjust these ratios. So you can add more conjugate base, which will make the pH a little higher, or you can add more of the weak acid, which will make the pH a little lower. One of the most important systems, buffer systems, actually is for the blood, and blood needs to be maintained at a pH of about 7.4. And the way that that's accomplished, well, actually there's several ways that that's accomplished, but one way that it's accomplished is through the carbonate-bicarbonate buffer system. So here's some of the relevant information about two important buffer systems. There's the phosphate system, which, because phosphoric acid is a triprotic acid, there are 3 different pKa's. The carbonate system is one of the important ones for regulating blood pH. And if on the next slide, so these two diagrams summarize one of the mechanisms of maintaining blood pH when you have the condition known as acidosis, or when you have alkalosis, which are 2 possible ways that the pH of the blood can be changed. If you go on in chemistry and you eventually take biochemistry, then this is the sort of thing that you would talk about in more detail. But for right now, I'll just mention it in passing.